So you've just come back from a surfing and you want to hang up your bathing suit in your dorm to dry. The wet bathing suit has a mass of 3 kilograms. In your room, you have a horizontal wire going from one wall to the other. As you hang the wet bathing suit on the wire sags. The tension in the wire is 60 newtons. So I'm just going to do part A, which is drawing a picture and a free body diagram. So the picture would look like this would be the horizontal wire in your room. You have the 2 tension lines, and this is like your bathing suit with an angle theta here, angle theta there. So these, since it's 60 newtons, this would be divided into 2. So tension for these is both 30 newtons, and the bathing suit is 3 kilograms. So now that we have the picture, we'll draw a free body diagram. So you'd have a singular dot. So you'd have your tension force pulling that way, your tension force pulling that way with even tension. So these would both be 30 again. And then you have your mg, which is just gravity. So what you're trying to find here is this angle theta that would make this, like if you split this in half, a perfect right triangle.
So after we found the free body diagram, the next problem is to find how much the wire sags and what is the angle relative to the horizontal, this line being the horizontal. So we know that our wet bathing suit is 3 kilograms and the tension of the wire is 60 newtons. And by knowing these, we can also use our force equation F equals ma. And we know there are 2 forces acting on the bathing suit, which is the gravitational force as well as the tension force. And because there's two lines that are affecting the bathing suit. Next, we know that the acceleration is 0 because the object's at rest. And from there, we can simplify the equation to 2ft equals fg. Fg is also mg for the gravitational force, and ft is 30 sine theta. From there, we can solve for sine theta, which is mg over 60. And solving for the angle, we can use sine inverse mg over 60 newtons, which equals our theta. And from there, we plug in our values, which is the sine inverse with m equaling 3 kilograms for the wet bathing suit, 9.8 meters per second squared, which is the gravitational acceleration, over the 60 newtons, which is our tension over here. And solving that, we'll get 29.34 degrees. And we know this is correct by checking our units, because from the top, if we multiply the mass of the bathing suit, which is kilograms, times meters per second squared for the gravitational acceleration, that will be canceled out by newtons, because newtons equals kilograms times mass over second squared as well, which means it's correct.
So part C of this equation wants to know what mass would be required to make the wire perfectly horizontal. So in this part of the problem, we can use the same equation and values from part B. So using F is equal to ma and subsequently Fty minus Fg is equal to may. We can, since the object is still at rest, acceleration is still 0. So that gets rid of the right-hand part of the equation. And rearranging the equation, we get Fg is equal to mg, and Fty is equal to 2 times 30 sine 0. And since it's sine 0 because we want the wire to be perfectly horizontal. Moving on. G would just be the force of gravity, the acceleration of gravity. And since sine 0 is just 0, this makes the left-hand part of the equation 0, and dividing by the acceleration of gravity, the mass required for the wire to be perfectly horizontal is 0 kilograms.